So what if you could build a digital system that had its own unchangeable constitution? Well, that's the core idea behind a really fascinating concept called the atomic kernel. It's a whole new way to guarantee that our digital worlds behave exactly the way they're supposed to.
But that begs a really fundamental question, right? Think about, well, everything from financial systems to collaborating AI. How can you be absolutely certain that two separate computers, given the exact same start and the exact same instructions, will get the exact same result? Without some central boss, how do you stop them from just drifting apart?
And this really gets to the heart of it. You've got two completely different worlds of computing here. On one side, you have our typical systems, which are always at risk of digital drift, where tiny bugs and differences can spiral into total chaos. We pretty much just hope they'll stay in sync. But the atomic kernel, it's proposing a whole different world, one where consistency is guaranteed through what's called deterministic replay, where results can be proven with math, and where you never have to trust an outcome because you can just recompute it yourself.
All right, so here's the plan. We're going to start by digging into this problem of digital drift. Then we'll explore the kernel's solution, this constitution for code. We'll see how its laws actually work, check out its strict ladder of authority, and finally uncover how this whole thing enables a brand new future of verifiable agreement.
Okay, so let's get into it. The main problem the atomic kernel is designed to solve is this thing called state drift. It's that maddening, unpredictable way that two systems that should be identical just slowly fall out of sync. And that leads to errors and a complete breakdown of trust, especially in decentralized setups.
So what's the solution? Well, the answer isn't just another piece of software. Think bigger. The idea is a foundational layer designed to be as reliable and unchangeable as, say, a country's constitution. It sets the absolute, non-negotiable rules of the road for any system you build on top of it.
And that is the whole idea behind this constitution metaphor. The kernel's laws have what the source material describes as normative authority. And what that really means is that they are the absolute, final, unchangeable source of truth for the entire system. It gives you a rock-solid, predictable foundation to build on.
Okay, so how does this digital constitution actually enforce its rules? I mean, how does it all work? Well, it all comes down to a few core, rock-solid laws that dictate how the system evolves. And we're not talking about physical time here, but a logical, step-by-step progression. It all starts with something called the seed. Think of it like the unique digital DNA for any process. You create it by taking some kind of input, a file, a message, whatever, and you run it through a standard crypto hash function, like SHA-256. Now, the key thing here, the crucial part, is that this is perfectly deterministic. The exact same file will always give you the exact same seed, every single time. So once you've got that unique seed, the replay process can kick off. You take that seed and you apply a fixed deterministic rule. They call it a transition law, which basically just turns the current state into the next one. And this creates a new state that is 100% predictable. You can just keep doing this over and over for as many steps as you want. Each step is like a tick of a perfect logical clock.
And this right here, this is the core constitutional claim of the whole system, pulled straight from the source. It is an absolute mathematical guarantee. If you've got the same law, the same starting seed, and you run for the exact same number of steps, you are guaranteed to get the exact same sequence of states. There are no ifs, ands, or buts about it. All right, but how do you protect that guarantee, right? To make sure it's never violated, the whole system is built with a really rigid structure. Think of it like a separation of powers. And this isn't just a suggestion. It's a strictly enforced architecture that stops any part of the system from overstepping its authority. This authority ladder, as they call it, has these really clear layers. At the very top, you've got the kernel. That's the constitution, the law. It has what's called normative authority. It sets the rules, period. Then below that, you have extensions. These can build cool new features using the kernel's laws, but, and this is key, they can't change them. And then way down at the bottom, you have projections. Think of these as things like a user interface or report. They're purely advisory. They have absolutely zero authority to change anything. And man, this quote from the source just nails it. You can have all sorts of fancy UIs, APIs, whatever, that package up and show you the system state, but they are fundamentally forbidden from ever redefining those core kernel rules. This is huge because it prevents what's called authority escalation, which is a major source of bugs and chaos in pretty much every other system. So,
What's the payoff for all this strictness? Well, this architecture enables the system's absolute killer feature, verification by replay. It means anyone can prove that a claim is true on their own without having to trust anybody. Okay, let's make this real with a simple example from the docs called deterministic agent coordination. So imagine you have two AI agents. Agent 1 does some heavy computation on a file, and then it goes over to Agent 2 and says, hey, I took this file, ran our process for 500 steps, and this is the result I got.
Now, how does Agent 2 know if Agent 1 is telling the truth or, just making stuff up? Well, it doesn't have to trust it at all. It just grabs the exact same file, calculates the seed for itself using the same public rule, runs the exact same transition law for exactly 500 steps, and then it just compares its own final result to the one Agent 1 claimed.
And boom, if the results match, the claim is proven to be true. And it's not proven through trust or persuasion or anything like that. It's proven with cold, hard, repeatable math. You don't need a central server or some referee to decide who's right. The proof is right there in the recomputation.
So, where does this leave us? What can you actually build on a foundation like this? Because this isn't just some cool academic idea. Having this kind of provable, deterministic system unlocks a whole new world of powerful applications.
I mean, the possibilities here are huge. You've got the decentralized agent coordination we just talked about, but you could also do perfect bug-for-bug replays of super complex systems. You could create tamper-evident logs that can't be faked. You could make sure scientific simulations are perfectly reproducible, which is a massive deal. The list goes on. And this final quote, again from the source material, I think it really captures the entire philosophy behind the atomic kernel. This is about a fundamental shift, moving away from building systems that we just hope will work correctly and moving towards systems where correctness can be proven by anyone anytime, just by starting from scratch and re-deriving the results. And that really leaves us with a final, pretty fascinating question to think about. What could we build in a digital world where perfect, verifiable agreement isn't the exception but the absolute default? What happens when that's the foundation we're building on? It's a pretty exciting thing to imagine. Thanks for tuning in.